Hi, in this video we are going to look at a couple of questions which involve around knowing the trigonometric values. And I've cut this section out of the website Maths is Fun because I think it just sums it up quite well. You need to know certain values for sine and cosine and tan. But I think this is quite a useful, simple way to remember it. If we look at this, it shows us that sine goes 1, 2, 3. So we need to know 30, 45 and 60 degree angles for sine. And we could think of it as root 1 over 2, root 2 over 2, root 3 over 2. And of course, root 1 over 2 would just be a half because root 1 is 1. And then cosine goes the opposite way. So it's going down 3, 2, 1. So the same values, but going downwards. And that will help us also to remember that sine starts from 0 and works its way up to 1 at 90 degrees. And cosine does the opposite. It starts at 1 and it works its way down to 0 for 90 degrees. So you might want to stop and think about that. So pause the video if you want to. I'm going to move on to a couple of questions. So first thing, this is question 29 from Corbett Maths. Now my only concern is the two questions we're looking at are both awarded 2 marks, which I think is unrealistic because there's a lot less work in this first question than there is in the second. So I'm slightly concerned about the scoring that they give. And as I've always saying, marks are important. Okay, so let's look at this question. Below is a right angled triangle. Show that angle X is 30 degrees. Include all your working. So let's start by thinking about what we've got here. So this is the angle we're interested in. And we've got the opposite and we've got the hypotenuse. And that should straight away lead us to sine, because sine is equal to the opposite over the hypotenuse. And if we're showing that X is 30 degrees, then the second thing is we need to know that the sine 30 is 1/2. Okay, and you can refer back to that table if you need to, but that is the information you need to know. So that means that we need to show that 4 root 2 over 8 root 2 equals 1/2. And just looking at that, I think we can pretty much show that, can't we? If we divide by 4 root 2, we are going to get 1/2. So we could just put a note, divide by 4 root 2, divide by 4 root 2, and we would get 1/2. So therefore, we have proved that X equals 30 degrees. Okay, so nice, straightforward one to start us off with. Let's move on to the next question, number 30. So below is a right angled triangle. Show that angle X equals 30 degrees. Include all your working. So again, let's mark it up. This time we have the side adjacent to the angle, and again we have the hypotenuse. And that should lead you to the fact we are looking at cosine as our trigonometrical ratio. And then, of course, secondly, we need to know that cos 30 is equal to root 3 over 2. And that is the information that you need to know. You just have to remember those certain values. Okay, so what we've got to do is to show that root 6 plus 2 root 3 over 4 plus 2 root 2 is equal to root 3 over 2. Okay, and already we can see that there's going to be more work involved in this. So what's our starting point? Well, our starting point is to remember that we need to rationalise this denominator. We've got a root 2 here. We know in our result we need not to have a root 2 and not a surd. So let's do what we need to do to get rid of that, which is to multiply it by its conjugate. So if we have got, let's write this out again. I'm going to put a big line across there. If we've got 4 plus 2 root 2, what we need to do to get rid of that surd is to multiply it by 4 minus 2 root 2. And of course, if we're doing that to the top, we must keep that fraction equivalent. So we need to multiply the top by the same. Okay, so that is our next step. Now we've got to multiply out our brackets. I might come over here just so I've got more room. So let's start with this. We've got root 6 times 4, which is just 4 root 6. And then root 6 times minus 2 root 2, which is going to give us minus 2. Root 6 times root 2 is root 12. And then we've got 2 root 3 times by 4, and that's a positive. So we are going to get 8 root 3. And finally, we've got plus 2 root 3 times minus 2 root 2, which is going to give us minus 4 root 6. Now, if you want to do that in your own pace, work it out for yourself, you can just pause this video and do it for yourself. Now let's do the bottom. And we know that the whole reason we multiply by the conjugate is because we're just left with the difference of two squares. So we've got 4 times 4, which is 16. Oops. And then 2 root 2 times minus root 2. Well, the 2 times 2 is going to give us 4. The root 2 times root 2 is 2. Be careful not to think of that as 4. So we've got 4 times 2, which is 8, and it's negative. And there's our difference of the two squares. Okay. Now let's tidy things up a little bit. So we've got 4 root 6 minus 4 root 6. So they're going to cancel each other out. And so what we're left with, and I'm going to write these the other way around only because there's a minus there. So let's do 8 root 3 minus 2 root 12 over 8. Okay, so we're slowly getting it down. I'm going to start going across now. So let's see what we can do here. Well, we've got root 3 here. We've got a root 12 here. So we can't take this away in its current form. But we can work out what root 12 is. And maybe I'll just do that off to the side. We can, if you're not confident with this, you could write root 12 as root 4, root 3. And then root 4 we know is going to give us 2. So actually, root 12 can be written as 2 root 3. We've got 2 lots of that, so we are going to get 4 root 3. And of course, that is going to give us 4 root 3 over 8. We can take out a factor of 4 and we will be left with root 3 over 2, which is exactly what we'd hoped for. Okay, so that is a much more complicated question than the last one. So you can see why I think it would be worth more than 2 marks. And it seems so complicated, but once you get used to that, using the conjugate, that will really simplify the bottom. And then it's just being careful and taking your time and thinking about your surds. And that's the end of this question and the end of this video.